Let's talk about density. Density is one of the physical properties. Density is actually an intensive property, which means that the density of a substance is based on what the substance is. So if you have copper versus lead, those two substances are different, so they're going to have different densities. And intensive also means that the size of the sample has no bearing. So if you have a huge block of copper and then a small piece of copper, they're both going to have the same density. You can see from the formula that this should make sense. Density is equal to mass divided by volume. And so as you increase the volume or size of your sample, the denominator increases. But as you increase the volume, you're going to increase your mass too, which is in the numerator. So the variables kind of cancel out there and you wind up getting the same density. So lots of activities you can do with density. You should really get at students' understanding and confusion with density and volume. Because they think if the substance is large, that it has a high density. If the substance is small, then it has a low density. Those are just some misconceptions that they have. Even if the substance is the same, they expect it to have different densities, which is not correct. So in the experiment that we're going to show in a minute, it's a sort of a discrepant event. Basically, you have a piece of wax, and you have water and alcohol. All three of those substances have different densities. And you have a large piece of wax and a small piece of wax. And basically you have those substances, you put them in the water, something happens. You put them in the alcohol, something happens. The students will a lot of times ask you to switch them out and see what goes on. But the neat thing is that the wax floats in the water and then will sink in the alcohol, and no matter what size your wax piece is, this happens. So that sort of gets at this whole idea of not confusing density with volume. So it's a neat discrepant event, and it's coming up in just a second. A good thing to do a math connection with density that I want to talk about is graphing. So when you think about a graph, and you think about a line and getting a slope. Slope is equal to the change in y, right, over change in x. Okay? And so if we look at this and this, we should see some similarities here. And so we can make a graph of m and v, mass and volume. So if we make a graph where our mass is on the y-axis in grams, and our volume, usually in milliliters, is on the x-axis. We can take, say for example, pennies. You can get the mass and volume of 5 pennies, the mass and volume of 10 pennies, the mass and volume of 15, 20, and so on and so on. And you'll get some data in lab that your students can take. Your students can then draw a best fit line through that data. And then they can use this line, their best fit line, to calculate the slope. And since slope is y over x, and we've graphed mass and volume, the slope of their line will equal their density. So this is a really nice math application that you can do with density. And you can talk to your students about why this might be necessary. If they look at they have 35 pennies and they start looking at the pennies, they'll see little differences in the pennies, like maybe one's got a nick out of it or whatever. And what this does is we get more of an average, more of an accurate value for our penny. If you can find old, really old pennies that are 100% copper, and then our new pennies, which are just copper coated and they have a zinc inner core, you actually get different slopes here for your lines, and they can figure out the different densities of the different aged pennies, which is a neat thing to do as well. So I just like to point this out with the math connection here, and really kind of driving home the point that In science, we want to apply our mathematics, and when we make graphs in science, it's for a reason, and a lot of times that reason is to figure out some value or to calculate some value. And this is a great place to do that. Okay? And so now you'll be looking at the experiment with density.